All right, welcome back. In this video, we're going to be continuing to look at geometric sequences. This is presented by 3Math Guys. Subscribe and go to 3mathguys.com. Um, so if we've got a geometric sequence, which is a sequence that's multiplying by the same amount over and over, how do we find what's called an explicit rule that describes the sequence? And so the way to go about doing that, I typically like to kind of put this in the format of a table. So I could say, well, this is my first term, and then this 12 is my second term, and third term, and so on. And think of this as an input-output relationship. So like, and you can call it, this is n, any number in my sequence, and so this would be f of n as my output. And there's a couple ways to find an explicit rule. And when we say an explicit rule, we're looking for a mathematical equation that will take this input value, for example, the number 3, and turn it into the output number of 36. Okay, so, and you might think, well, oh, okay, I could just go, 3 times 12, but does that work for every input and output? Can I go 2 times 12? And it doesn't quite work. So we need something that will turn the 1 into the 4, and the same rule will turn the 2 into the 12 and the 3 into the 36. And the advantage of finding this explicit rule is I could say, okay, what's the 81st term going to be? And I can just use my rule and find it. So let's kind of walk through how to do this. First, you need to find the common ratio. And if you saw the last video, these are going to be the same patterns we used in that one. So I'm going to go times 3 over and over to get from one output to the next output. Okay, and so one way to think about doing this is to ask yourself, what if there had been a 0 term? Well, I would have had to multiply 3 to get it to turn into the 4. And so if I'm multiplying by 3 to go this way, I'm going to be dividing by 3 to go this way, and that would end up giving me 4/3, 4 divided by 3, as my 0 term. And so basically what I've got here, if I use this 0 term technique, is if I say 0 is where this sequence is starting, the rule is I've got 4/3 and then times 3 times 3 times 3 over and over and over, right? And we can show that this times 3 is repeating. Remember, repeated multiplication is what exponents are. And so really what I've got going on here is I've got 4/3 times, and I'm just going to use parentheses here, times 3. And how do I show that times 3 keeps on repeating? I'm going to use an exponent and say it keeps on repeating n number of times. And so kind of what do we mean by that? Like on this third term, how many times has times 3 repeated? If n is 3, this has happened 1, 2, 3 times. If n was 4, then it's happened 1, 2, 3, 4 times. So if I want to show what's happening, I've got 4/3 times 3 n number of times, because that'll be however many times it takes to get to the nth number. And this rule will turn any input into the output. If I know what my input value is, like let's say I want the third term in my sequence. Well, if I take this rule, 4/3 times 3, and I plug in a 3, okay, so I want my third term. If I take 3 times, I'm going to get 27 times 4/3, and you'll end up with 36. So if you plug this value in for n, it'll end up telling you the output value. Okay, hope that kind of gives you an idea. Now, that's not the only way to write one of these explicit rules. Another technique, probably the more common technique, is don't go through the hassle of trying to figure out that 0 value. There's a way to do it just from the first term. And so if I start at the first term, where did this thing start at? Here, we'll kind of make a break here. So I could say any number in my sequence is going to be, let's say we start at 4, and then I do times 3 over and over and over, right? Times 3. Repeated over and over and over. But now when I start at the first term, what I end up having is at the third term, how many times has that times 3 happened? Well, it's happened twice from the first term. And at the fourth term, it's happened 3 times where it repeated. So at the fourth term, it's repeated 1 time less than 4. And so the way to write that mathematically is I can say I started at my first term of 4, times 3 is happening over and over, n minus 1 number of times. That's how many times it's repeating. So for example, if my n is 4, n minus 1 would be 3, which means it's repeated 3 times at the fourth term. And this rule is equivalent to this rule. Okay, those are going to be equivalent rules. They both work. They're both an explicit rule for this sequence. And in fact, I could even say something like f of n equals, like let's say I started at the third term. Like let's say this thing started at 36, right? And then what's it doing over and over? It's going times 3 over and over and over. Well, if I start here, then the times 3, I have to kind of backtrack and not count these, right? If I'm starting at the 36, it's like these 3 don't count. So I'm saying my times 3 has happened not n number of times, but n minus 3 number of times. And I started at the third term. Just like if I start at the first term, I put n minus 1. If I start at the 0 term, it's n minus 0, which is just n. And typically, I've seen it most often this way with n minus 1, but just know that it works starting at any term. And so if I wanted to find, what's the 100th term in this sequence, well, I can just do, plug in 100. 100 minus 1, 3 to the 99th power times 4, and then I'll know what my number is going to be. Okay, so let's look at a couple other examples. I'll go a little bit quicker on these. All right, so let's say I want to find the explicit rule for this sequence. Well, I'm going to kind of use my shortcut that we learned, and I'm going to say, well, if I start at my first term, of negative 72, what's it doing over and over and over? And we don't want to say divided by 2. We want to say that this is times 1/2. Right, times 1/2. Well, times 1/2 is what's repeating. So my rule is negative 72 gets multiplied by 1/2 over and over. And the way I show over and over is with an exponent. When you multiply repeatedly, that's an exponent. And since I started with my first term, it's going to repeat n minus 1 number of times. And again, just to clarify, in case that didn't sink in before, this is my third term, right? Well, at my third term, how many times did 1/2 repeat? Twice. So if my n is a 3, the repetition happened 1 less time than 3. It happened twice. So n happened, n minus 1 is how many times it repeated. Okay, so let's take a look at a couple others. So let's see, first thing you want to do is figure out what's the common ratio, and we did that in my last video, and so this one is multiplying by 2/3 over and over. 2/3, that's our common ratio. And so if I want to write my rule, I can say, well, my rule is that any term in my sequence, any value in my sequence is going to be found by taking, I can take my first term, 12. That's going to repeat the pattern of times 2/3 over and over and over. So I can say 2/3 to the n minus 1 power. Okay, and so really the key values you're looking for are my first term is how I'm going to start my rule, and my common ratio is what is going to have the exponent, and then n minus 1 just shows that I have repeated multiplication happening, and I use n minus 1 because I started with the first term here. Okay, and a common mistake is to switch these two. So you don't want to write the rule, I have 2/3 times 12 to the n minus 1. That would not be correct because times 12 is not repeating. Times 2/3 is what's repeating. So that's the part that has to have the exponent. Okay, so be careful of that. And let's look at one last example. Okay, so, well, let's see here. I could say my rule for f of n is going to be 5. And then what's repeating? We've got not times 2 because it goes from positive to negative. I'm going to go times negative 2 over and over and over. And since I started with my first term, I'm going to say n minus 1 is the number of times it repeats. Okay. Now, you could also go back to that first way I showed and say, well, if that's the first term, what would the value have been if there was a 0 term? And instead of, going times negative 2, it's almost like I'm taking my 5 and dividing by negative 2. So I could say an equivalent rule here. Another way to write it would be to say negative 5 over 2 is getting multiplied by negative 2 over and over and over n number of times. So if I use my 0 value, I'll just put n, right? This is my 0 term. If I use my first term, it's minus 1. If I use my third term, I'd put minus 3. All right, so hopefully that helps you understand how to find one of these rules. And so that'll do it.